All right, as a request, here's number 7 and number 9 out of the review on page 91. So our instructions are find the limit L, then use the epsilon delta definition to prove that the limit is L. All right, so again, we have 4 things here. So if we start taking a look at number 7, come on here. All right, number 7, we've got the limit as x tends to 1 of the function 3 minus x. Okay, and so if you simply just plug 1 in, then you get 3 minus 1 is 2, and so the limit should be 2. And now we have to prove that that limit is 2. So the 4 things we need. Number 1, we need a function. Okay, all right, fine. By the way, the other thing we need to check for, since this is review, then they can draw from any of the 5 sections. And one of the things that they talked about in section, I think it was 3. 3 started out, or I remember it's 3 or 4. Anyway, one of them said that in order for a limit to exist, the limits as x approaches c from the right must equal the limit as x approaches c from the left, and the limit must exist, and that sort of thing. And so, in order for the two-sided limit, which is really what we're looking for here, then the limit as we come from the right and the limit as we come from the left must all come from the same thing. Since this is a linear function, then it's continuous throughout all of the real numbers, and therefore the limit exists. So we can very quickly verify that we can have an existent limit. All right, back to the 4 things. We've got a function, then we need some c value. C value is what the limit or what x is tending towards, and so we do. That's 1. Then we need a limit, an L value. L value is 2. And then the very 4th thing, and the one that they don't necessarily give you, you need an open interval. Okay. That open interval can be whatever you want, but it's very common to center it at whatever your C value is. And then you simply, the easy way for me is to simply go one above and 1 back. This may be limited by the style of the function, but in the linear function we're safe. And so we simply go, I'm going to choose to go from 0 to 2. And if I do that, that means that my delta value is going to be equal to 1. Because remember, this is going to be plus or minus delta. So this would be 1 minus delta, comma, 1 plus delta. And that would be my width, the width of the open interval I'm considering. And since it's 1 minus 1 is 0 and 1 plus 1 is 2, then my delta value is actually 1. And so I'm going to use that delta value later on. Okay, so as we're looking at this, now we have to show that for all epsilon greater than 0, so for all epsilon greater than 0, there exists a delta greater than 0 such that 0 less than the absolute value of x minus c less than delta means that f of x minus the limit is less than epsilon. Okay, so for all epsilon greater than 0, there exists a delta greater than 0 such that as long as the distance between x and some approachable value is less than anything we can think of, implies that the difference between the function value and the limit squeezes down into virtually nothing, or as small as we need it to. Okay, so that's just from the definition. All right. Now, we need to figure this out. And so what we're going to do is I'm going to start with the function and its limit. And so I've got, because delta typically depends on epsilon. And so the function is 3 minus x. And then minus, what's our limit? 2. Okay. All right, so now we have that is less than epsilon. If we do what's inside here, then we get the absolute value of 1 minus x is less than epsilon. But this 1 minus x is the same as -1 times x minus 1. All right, so I'm going to use this idea right here, this equality, to change the way the inside looks. And that means that if I use that, okay, that means that I can take -1 times x minus 1, and that's less than epsilon. Well, we did prove one thing, that if you have this setup where you're having the absolute value of two numbers being multiplied, that's equal to the absolute value of the two numbers being multiplied, or the two absolute values being multiplied. Okay, so we can actually call that the same. Now, if we do that, the absolute value of -1 is 1, and therefore we get the absolute value of x minus 1 is less than epsilon. But if we take a look at what we had up here, we also noted that x minus c is less than delta, and so we really wanted x minus c, which is 1, is less than delta. And so using these two ideas, we're going to let delta equal epsilon. Okay. All right, so now we have used delta, or we've used epsilon to find delta, find a value for delta. Now we have to go back and show that this part is true. So we have to show that because delta is less than that, or because this is squeezed down less than delta, it's also the function, the difference between the function and its limit is squeezed down below epsilon. Okay, so this means that we have, basically all we're going to do is we're going to work backwards. So we have the absolute value of x minus 1 is less than delta, but delta equals epsilon. So now we have -1 times 1 minus x is less than epsilon, because we can interchange the two now. All I did is I multiplied through by -1 on the inside. Okay, and now I can make this look different by saying this is going to be the absolute value of 1 minus x. Again, because of this property up here, I can split them up and undo them effectively. Okay, that's less than epsilon. But I can rewrite 1 is equal to 3 minus 2. Okay, so now I can write it as, this implies that 3 minus 2 minus x is less than epsilon, which is 3 minus x minus 2 is less than epsilon. And as you see, 3 minus x minus 2 is less than epsilon. And it's exactly what we had up at the top. So here's our answer. Here's what we had to show. And you'll see that the two are identical. And so this is done. Now, the end in math, by the way, the old way of doing it is QED. I believe that's, let's see, quo or quad, I forget which. QUOD, I think it is quad erat demonstratum. And that just means what is to be shown. So we proved it. We said as long as delta is equal to epsilon, while that mess is less than delta, then this mess is less than epsilon for all epsilon. So we're done.